everybody. This is the third segment of the geology time. Remember, that's the first chapter in historical geology, and this is Dr. Anna, your geology professor for this class. I stopped at the uniformitarianism in the previous segment, so now the next principle you will have to know is the unconformities. The unconformities are about missing time throughout the layers of the rocks, basically the Earth history. If you think about, like, right now in Virginia, we are on the continent. So right in this moment, there is no deposition, which means that when we go back later, like a couple of hundreds of million years from now on, you look at the layers below and you look at the layers above, and just the time where we are in right now is going to be missing time. Nobody will know what happened. We know that it has been a continent, but other than that, we don't know much about it. So basically, there are different degrees of missing time, just a little bit of time, a little bit more time, and a lot of time. Based on that, we classify the unconformities: nonconformity, angular unconformity, disconformity, and paraconformity. So let's go through them one by one. The first one we're going to cover is the nonconformity. When you have nonconformity, basically what that means is that you have no idea how much time is missing. So what we have here is an igneous rock, igneous or metamorphic. Igneous or metamorphic rock. Remember from physical geology, the different rocks? If you have igneous and metamorphic rock, or metamorphic I should say, and on top of it you have sedimentary rocks, then the boundary between igneous or metamorphic and the sedimentary rocks are going to be called nonconformity. We don't really know, we have no clue how much time might be missing there. So therefore, anytime you see a conformity in between igneous or metamorphic rocks and sedimentary, it's going to be nonconformity. Remember, nonconformity. On this side, you can see an example. Here is granite, an old granite like in Colorado. And on top of it, you have this red sandstone. We have no idea how much time is missing there, because this granite, most likely, if I'm right, this is the Colorado granite, and that is 1.7 billion, and these rocks most likely Cambrian or something, which is 540 million years. So there is a billion year missing right there, or 1,200 million. So we don't really know. That's why we call this nonconformity. Remember, anytime you have igneous, it could have been metamorphic, igneous or metamorphic, and a contact with sedimentary rocks, we call it nonconformity. The next one is the angular unconformity. When you got angular unconformity, that just means that you have layers coming up to an erosional surface with an angle. So it's very important that there is a surface, which is the unconformity right there, and the layers below and above have different angles. See, the layers which are coming up to the unconformity, coming up with an angle, and the next layers are horizontal. This is what we call angular unconformity. In the lab, we're going to go through more of this, and we're going to practice it, so don't worry if you don't know, but it's pretty simple. There's an example. I took this picture in Oregon. These are not very old rocks, but still, if you look at this surface right here, that's the unconformity. And you can see that to the unconformity, these layers are coming up with an angle. You see right there? They're coming up with an angle. And there is already two layers on top of it, and they are horizontal. So we call this angular unconformity. When you have an angular unconformity, you know that there is a big chunk of missing time, because before these horizontal layers, these layers were laid down horizontal, then plate tectonic had to come, and they tilted these rocks. Plate tectonic, because of plate tectonics, the rock became tilted, and then there was erosion, and then on top of it, you got the horizontal layers. So we know that at least 50 to 100 million years missing there. So this is what we call angular unconformity. Okay, the next one is what we call disconformity. When you have disconformity, all you have is an erosion in the layers, and you can see erosion because it's a very irregular surface. These are not like straight lines, but irregular surface. You sometimes even see low river channels or something like that. So you know that there was a time missing, means there was no deposition for a while, but the layers below the unconformity and above the unconformity are parallel with each other. We call that disconformity. In this case, you're probably not missing much time. There is not too much time missing, probably 1,000,000 years to 10, possibly just some 100,000s of years. So it's definitely not as much as when you have an angular unconformity. And this is a good example for the disconformity. I don't have slides for the very last one, the so-called paraconformity. The paraconformity is you just know that a little bit of time is missing. There is not even erosion surface. So that is the hardest probably to pick out. So you don't even have to worry much about that. And on this slide, when you play the slideshow, you will see that this slide shows you different types of unconformities. So this is a really good one. When you play the slideshow, it will play. Actually, this one will play too. So this one will play too. So just do it while you're watching the slideshow. And this here is the very last principle, the principle of faunal succession. And this is very important too. Basically, this is based on evolution, and it's very important. However your belief system goes, you have got to know this. You have to understand that the life forms on Earth have evolved over time, and that the species appear then often go extinct, and fossil assemblage follow one another through time in an orderly and determinable fashion. So we know that the evolution is a one-way street. There is no going back. If you had a species at one time, it will not occur again. If it went extinct, it's gone. So therefore, we can use that particular fossil to characterize the time period it lived in. So these are extremely important. Without this principle, we couldn't find oil. Most of the geologic resources are formed based on this principle. The fossils are very, very widely used. You couldn't drive your cars without it, basically. So you have to understand for this class that evolution is a one-way street. So the species only occur at one certain time in the Earth history, and they will never come back. So therefore, we can define the relative ages of rock units by them. So these are the 8 principles, and you will have to know them without question. And this slide, as you will play it, you will see it's amazing, and it will show you all the relative age principles, and it's very good. It explains everything, like self-explanatory, and in labs we'll do it anyway, so you will get lots of help on this.